Hello everyone, I am Sunil and today I will be discussing on the topic self-adaptive intelligent agents. This is a part of my course AI Foundations and my roll number is 25951A05N8, semester 2 and AAT 1. Self-adaptive intelligent agents. Fundamental of adaptive intelligence, real-world application and use cases, technical architecture and implementation, future direction and strategic consideration are the content of this. First one is fundamental of adaptive intelligence. Core concepts and definition. Adaptive intelligent agents. There are five main topics in this. First one is adaptive intelligent agents. Next is adaptive versus non-adaptive systems, feedback loops and learning, environmental sensing and response, historical evolution. Autonomous system modify behavior based on environmental feedback and continuous learning mechanism. Adapt Adaptive versus non-adaptive systems. Adaptive system dynamically adjust strategies. Non-adaptive systems follow fixed regulation of environment. In an adaptive system, dynamic means they can change or not change in this, and non-adaptive system follow a fixed pattern or rules. Feedback loops and learning. Feedback loops enables agents to perceive outcomes, learn patterns, and refine decisions autonomously. Environmental sensing and response. Real-time sensing combined with response optimization ensures agent adapt quickly to dynamic conditions. Historical evolution. Evolution from rigid rules-based system to intelligent adaptive agent. Yeah, autonomy and environmental response. Fund Foundational technologies. There are five topics in this. Machine learning framework, real-time processing, communication protocols, sensor integration, knowledge representation. In machine learning frameworks, neural networks, reinforcement learning, and decision trees enable intelligent decision making capabilities for adaptive agents. Real time processing, computational requirement, and latency management ensures a responsive agent behavior in dynamic environmental. Communication protocols, agent to agent and human agent interaction standard enables seamless coordination and meaningful collaboration across systems. Sensor integration, multi-modal input processing, and fusion techniques facilitate comprehensive environmental perception and awareness. Knowledge representation, ontologies, semantic networks, and contextual memory systems organize and retrieve critical information efficiently. Adaptation mechanism. There are three steps in this: sense and analyze, decide and act, learn and feedback. First is sense, and then decide, and then learn by feedback. Environmental data collection, pattern recognition, data interpretation, and contextual understanding for an informed decision. Decide and act. Then it decides decision making algorithm and strategy, selection guide action, execution and efficient resource allocation process. Learn and feedback. Performance evaluation and model refinement integrate results, update knowledge, and continuously improve adaptive capabilities. Let's discuss about performance metrics and benchmarks. Adaptation speed, learning efficiency, robust assessment, scalability performance, domain specific KPIs. Memory's time required to organize environment changes and execute appropriate response. Faster adaptation enables agent to maintain efficient effectiveness in dynamic conditions and computer scenarios. Learning efficiency. Quantities data samples needed for measurable performance improvement, higher efficiency reduces training overhead and accelerate deployment ti- timeline significantly. Robust assessment, scalability performance, domain specific KPI establishes tailored performance indicated across varied applications. Domain enables complementary technology, benchmarking, and comparative analysis between different agent implementation and use cases. Metric, definition, target range, application domain. Adaptation speed, definition, response time to environment. Target range, less than 500 meters. Application, real-time system, learning efficiency, robust score, consistency across edge, greater than 95 percentage. Critical operations, scalability at index, performance ratio of 10x, greater than 0.85. Enterprise deployment, domain KPIs, task specific success rate 5 percentage, greater than 90%. Vertical solutions. Second is real world applications and use cases. Enterprise and business operations. Supply, smart supply chain management, autonomous customer service, financial trading systems, human resource optimization, manufacturing process control, smart, smart supply chain management, dynamic routing and inventory optimization powered by supply, self-adaptive algorithms enhanced operations efficiency and reduce supply chain costs significantly. Autonomous customer service, contextual learning, chatbots deliver personalized recommendation, improving customer satisfaction and engagement through intelligent interactive financial trading system, market adaptive algorithms, access risk and manufacturing process control, predictive maintenance and quality assurance system maximize resource efficiency while minimizing production downtime and detects human resource optimization, intelligent talent acquisition and employee engagement prediction systems and strategies. Healthcare and life science. There are five topics in this also. First is clinical decision support. Adaptive diagnosis system learning from patient outcomes continuously improve accuracy and treatment recommendation systematically. Discovery. Intelligent agent optimize molecular screening and compound selection, accelerating research timelines and reducing development costs significantly. Personalized medicines. Treatment adaptation based on individual patient response enables customized therapies, improving efficiency, efficacy, and patient satisfaction rates. Op- Hospital resource management, dynamic staff allocation and equipment utilization, optimize operational efficiency, reducing wait times and minimizing resource out wastage. Health monitoring system, continuous adaptation to individual health patterns enables early detection and intervention, improving pre- uh, preventive care outcomes significantly. Autonomous system and robotics. Initial deployment, basic environmental adaptation and obstacle evidence and avoidance capabilities implemented for foundational automation, autonomous operations, operational learning, task optimization and efficiency improvement through continuous learning from operational data and feedback, advanced autonomy, Complex decision making and multi-agent coordination enables a sophisticated autonomous system behavior predictive fears. Anticipatory behavior and proactive problem solving capabilities reduce response in time and enhancement system reliability. Collaborate phase, human agent teamwork, and shared learning system create a synergic operational framework for optimal result. Smart cities and urban infrastructure, traffic management, energy distribution, environmental monitoring, public safety, citizen services, real-time congestion detection with adaptive signals control, and intelligent route optimization for efficient traffic flow, energy distribution, demand prediction, and load balancing integration with the renewable energy sources, but for sustainable development. Environmental monitoring, public safety, citizen services. Third is technical architecture and implementation. System design principles, foundation layer, processing layer, interface layer, algorithm layer, decision layer, foundation layer, robust sensing infrastructure and data quality assu- assurance ensure reliable input data for all downstream processing systems and operations. Processing layer, real-time processing energies and computational platforms enable rapid data analysis and system responsiveness to changing conditions. Interface layer, user interface transparency and explainability mechanisms ensure human oversight, trust, and understanding of autonomous agent operations. Algorithm layer, adaptive algorithm and machine learning models provide intelligent patterns recognition and predictive capabilities for autonomous decision making. Decision layer, decision making frameworks and action execution system translate to computational insights. Responses. Machine learning and AI integration. Supervised versus unsupervised learning. Algorithm performance trade-offs. Supervised versus unsupervised learning. Supervised learning provides high accuracy with labeled data. Unsupervised learning adapts better to unlabeled dynamic environment with the lower computational overhead. Accuracy requires extensive labeled data sets and longer training, adaptation speed, prioritize lightweight models and incremental learning for real-time responsiveness. Reinforcement learning approach. Reinforcement learning enables autonomous decision making through reward mechanism, balancing exploitation, trade-offs for adaptive agent behavior, optimization, model training, and validation. Training demands substantial data and computational validation uses cross validation, adversarial testing, and a real-world simulation to ensure robustness and convergence. Pipeline and knowledge management. Data acquisition, data processing, storage and retrieval, integration, quality assurance. Data acquisition, multi-source collection with initial validation ensures comprehensive data gathering from diverse origin reliably. Data processing, cleaning, normalization, and feature engineering transform raw data into structured acquisition intelligence efficiently. Storage and retrieval, knowledge-based management and enables the rapid access, optimization for a seamless information retrieval across systems. Integration, seamless data flow across system components ensures a cohesive connectivity and a synchronized operations throughout architecture. Quality assurance, continuous monitoring and error 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 correction maintain data integrity with the consistent and reliable throughout pipeline lifecycle. Scalability, scalability and performance optimization. Architecture pattern, latency reduction, resource management throughout matrices, load balancing. Future direction and strategic consideration. Emerging technologies and innovation. Quantum computing, federated learning, explainable AI, multi-agent system, human AI collaboration. Ethical and responsible development. Core principle, value alignment, privacy protection, bias mitigation, regulatory compliance, accountability mechanisms, transparency requirement. Core principle, value alignment. Industry and market outlook. 20, two- in 2024, current state. Enterprise adaptation, accelerating rapidly with a regulatory framework emerging to guide development and ensure responsible deployment. 2025 to 2026. Near-term growth, specialized application and industry-specific solution expanding across healthcare, finance, and manufacturing sector globally. 2027 to 2029. Medium-term evaluation, cross-domain integration, enabling autonomous ecosystem where agent collaborate seamlessly across multiple business functions and industries. In 2026, the space-led application and industry expands across healthcare, finance, and manufacturing sectors globally. Till 2030, long-term vision, AGI Foundation, developing with human agent, partnership, models redefining workforce dynamics and organizational structure permanently. Strategic recommendation and best practices. Use case definition identify high impact measurable business problems to maximize agent effectiveness and ROI success. Data quality investment, ethical guidelines, continuous optimization, incremental implementation, cross functional teams, human oversight. Thank you.